These are two questions on SAT Practice Test 6 in Blue Book, the Blue Book app. And this is the math section, 2, hard. And so the first question is 20. And when I say hard, it doesn't mean that the questions necessarily may not seem hard to you. They may not be hard to you. It's just if you get enough right in the first section, you get the hard second section. That's what I mean. All right, so this has a table x and g of x. The first thing, I'm gonna just answer these with Desmos. Desmos doesn't do g of x because it thinks the g is a function or g is a variable. So you put x and y. So I'm gonna put that table in there and momentarily. The table shows 3 values of x and their corresponding values of g of x, where g of x equals f of x plus 3, f of x over x plus 3. F of x is another function. And f, this function f of x, is a linear function. What does a linear function look like? It looks like y equals mx plus b. Because if I try to do a regression with, even if I do y and then f of x in the regression, and I'll show it, it's not going to know what to do. So I have to make g of x, or what I'm going to call y, some function that includes a linear function, and I'm just going to call it this. So watch, I'll put the table in, bap, and I got x1, y1, and I put minus 27, 3, and then I put negative 9, 0, and 21, 5. Whoops, not 215, 21, 5. And now, watch what happens. If I try to change this to g of x, it doesn't know what to do. I say, oh, it's a regression. I have to put g of x1, or I'm going to use a regression. It says this, too many variables. It thinks g is a variable, so I have to use that y1. And then, if I make my function, instead of using g of x equals, I'm going to put y1. This is the g function, equals. And then I'll put f of x, but I'm not going to call it f of x. I'm going to call it mx1 plus b. And then there's one other thing I have to change here. You may already know it, x1 plus 3. And I can't do equal. I have to do tilde, so it knows to make a regression. And notice how it's gone right through those dots, through those points. If I put f of x on the top, it's not going to know how to make a regression. It's trying to make two different regressions out of the same values, and it's not going to know how to do that. Look at it. It misses the points. You can see that right on the graph. So I'm going to put back mx1 plus b. And now I'm done, because the question asks, what is the y-intercept of y equals fx? It's going to be 0, and then a lot of times it's called b, because in the linear function, it's mx plus b, so 0b. b is 36, 0, 36. That's the answer, just like that in Desmos. The next question I'm going to do is, same test, SAT, Practice Test 6 in Blue Book, Math Section 2, hard, and this is question 22. The function f is defined by f of x equals ax squared plus bx plus c, where a, b, and c are constants. Do not watch this video, by the way, unless you've already worked Practice Test 6, because you don't want to have the answer before you work the practice test. I'm going to put that in the title or in the notes. The graph of y equals f of x in the xy plane passes through these points, 7, 0, negative 3, 0. If a is an integer, that means it's like, it says greater than 1. So 2, 3, 4, 5, 6. Which of the following could be the value of a plus b? And then it's got 4 choices, negative 6, negative 3, 4, and 5. So I'm again going to put in my table. And my table will have 7, 0. It's given me the zeros of this. And negative 3, 0. Whoops, not negative 30. I always do that, negative 3, 0. And now, if I just put in a regular quadratic regression, which I will do there, notice I put quartic. I thought that was a quadratic. There's quadratic. Notice it doesn't have an A, it doesn't have a B, it doesn't have a C. So I can't just use the built-in regression. I have to build it myself. And I'm going to put y1 tilde ax1 squared plus bx1 plus c. And now I just have to set a value for a. Okay, it says an integer greater than 1. So I'm going to put 2. I'm just putting the next one up. And oh, look, let me see. I'm going to put a plus b because that's what I want. And it says -6. A plus b, -6. That works. What if you didn't happen to pick a equals 2? You said, well, 10 is an integer bigger than 1. Yes, it is. But look at b is -40. A plus b is -30. -30 isn't there. Okay, you said, what if I go the wrong way now? What if let's say I'll make a as big as 100. What if I go to 11? Well, now b is -44. It's -33. See, as I get bigger, that number's getting to be a larger and larger negative number. Well, I want it to be a smaller negative number or start to become a positive. So I have to go smaller than 10. All right, let me try 5. I'm just saying, what if you didn't put in 2? I'll try 5. It says -15. Still too negative. I'll try 3. -9. Nope, I'm getting close. 2. So if you don't put the right number in right away, you can very easily, just by moving it one direction and the other, see that you have to make a smaller if you pick something bigger than 2. But you do have to stick to this, where a is an integer greater than 1. You have to stick to that in order to get this to work. I'm going to try one other thing. Let's see. I don't think this will work. What if I say a equals, and I give it a range? Let's say 2 to 200. Oh. Well, it's done something very strange there. Let's see if I can see the whole list. Yeah, for some reason, I thought maybe I could, see it all at once, but it's doing something. Oh, because it's not going up by integers. Let me try this. 2, 3, 4, 5. Nope, it's still. For whatever reason, when I try to put in a list of values for a, it's coming up with very odd, and it doesn't even show me. It doesn't even show me the results of that, and now it's got b is -7.1. So I'm not sure what that's doing. So you have to set it a equals just a number, and then it'll work. I just thought maybe I could put a list and then look at all the different solutions and then see which one it was. But didn't work like that. This would be the simpler way to do it anyway. All right, so there's 2 questions on SAT Practice Test 6, Math Module 2 Hard, done with Desmos.